Good afternoon, everybody. Thank you so much for being here today. For those of you who don't know me, my name is Mitch Flickinger. Been with D&H Distributing for 13 years now. Been on the Intel team for 10, supporting the whole data center product lineup. So for those of you who are familiar with PCSD, which evolved into DSG, which is now DCAI, you probably have ran into me somewhere along the way, and may have even helped you put a server together. But anyway, we're here today we're going to cover the Intel server innovations for the modern data center. I'm joined with a 20 plus year Intel veteran, Travis Polina. He supports the entire channel and partner ecosystem. He's been working with client, edge, data center. And one interesting thing he had mentioned is that he works with new Intel startups. So maybe he can give us a little bit of details on that, because I'm personally intrigued. I thought that was super cool. So we're really excited to have him here today. As of today, he's responsible for and focused on Intel's global data center channel and partner business. And that's exactly what we're going to be covering today. We're not going to do an hour of AI, so some of you might be excited to hear that. There'll be a little bit of that, but there's other verticals and markets we need to focus on that are extremely important in holding up today's infrastructure. So without further ado, and if you have any questions, keep an eye out for polling questions. And if you have any questions along the way, feel free to drop them in the Q&A. I'll do my best to answer it. But if we need to interrupt Travis, he has no problem with that. So we keep it formal in that respect. But anyway, without further ado, Travis, thank you so much for being here. Go ahead and take it away.
Oh, thanks for the introduction. Appreciate it. I will say just a preview of some of the startups I was part of for a while. Given the state of storage and memory in the ecosystem right now, for those that have been around any length of time, Intel was in the Optane storage and memory business for a while, right? 3D XPoint memory in a joint venture with Micron. I spent a couple of years doing that, building that business out through the channel, and now we look that business is gone. Given the state of storage and memory, I kind of wish we were still in that business. I think that'd be a good place to be right now. But with that introduction, let's go ahead and get started. You're all in the business, right? So you see this every day. The data center of yesterday is very different from the data center of today. And what the requirements customers are looking for continue to evolve, right? It wasn't that many years ago when a normal data center deployment was a couple servers sitting under a desk someplace, right? For a long time, we were complaining about DTOS, desktop on a side, that people used as a server. And it was pretty homogeneous how a data center was put together. Over the past 10 years, that has evolved dramatically. When you talk to partners and customers today, you can't have a conversation without addressing AI. AI is everywhere. In time, AI will literally be just another workload. We won't even talk about it as this really fancy thing anymore. But today, everybody's still asking about AI. Throughput, latency, performance, still critically important to the conversation. Security becomes more and more critical. And I'm not going to go super deep into security today. If that is something that anybody wants to dive into, please reach out and we can have a separate security conversation. A lot of that's being driven by AI, right? We need secure AI. We want to do AI, but it has to be secure. So security is becoming much higher priority in much of these deployments. And then it's the traditional TCO, cost, efficiency, sustainability, software compatibility, right? I keep seeing stories in the press that some big hyperscaler wants to open nuclear facilities. One of them is talking about turning back on 3 Mile Island. There's talk about putting data centers on the moon, for real. That's not realistic for most enterprise, but it does help accelerate or help accentuate the story around we have to be able to do this efficiently. Cost matters, right? Throughput, latency, performance, it all really matters. So these are all weighing much heavier on that decision criteria now when customers are looking at how do I really evolve my data center? What I'm going to get into is how Intel is architected our solutions to address all of these problems. If you look at it today, where are people actually spending their money? If you watch any of the news or read any of the trade regs, you think everything's going AI. Just do a quick slice on visual on this. AI is about 25, call it 30% of the overall spend. The vast majority of what data centers expense is today is still in some of those more, call it traditional markets, HPC and data services and web infrastructure, microservices and cloud. Even within AI, and I'll get a little more into this in a couple slides, the vast majority of that AI spend is on what we would traditionally call machine learning or deep learning or natural language processing. Generative AI, large language models, ChatGPT, which is what seems to take all the oxygen out of the room, is actually a fairly small percent of the overall enterprise data center AI spend. So where's most of the business happening and where's most of the growth happening? Traditional AI, and then those more traditional infrastructure and web applications, HPC, data services type markets. We also see a rapidly evolving ecosystem around cloud. So if you think back, not that many years ago, cloud was the big fancy esoteric thing, right? Everybody had to have cloud solution architects. Everybody had a cloud strategy. What are we doing with cloud? That has moderated a bit. So I don't have the 25 data yet because this survey will be redone at the end of 25. This is from Gartner. When they looked at the end of 23, they went and looked at what's happened with the on-prem data center business relative to colo, call that hybrid cloud or anything else you want, versus public cloud. And it was pretty clear public cloud was growing very rapidly. CAGR of about 24%, on-prem was about 8%. When they did that exact same analysis with the exact same customers, 12 months later, that had balanced a bit. Cloud is not going away, obviously, ever, but the balance between what customers are doing on-prem and what they're doing in the cloud has balanced a bit. So from 23.5% to just about 18% cloud growth, the on-prem business grew just about double. In aggregate, the market's grown about what the market does, but there's been a balance. And what that is largely driven by, part of it is regulated industries and so forth, where data has to be on-prem. And certain countries and certain markets are getting much more demanding, I guess, that data needs to be on-prem. Some of that just because of data sovereignty concerns, some of it being driven, again, by AI. We aren't comfortable with the security in the cloud. We're not comfortable with the cost of bringing all the data to where the AI is. There's a bunch of different rationale for it, but we've seen a bit of a balance between what's happening on-prem and what's happening in the cloud. I'm kind of waiting to see the study on this in 25 because I think we'll see kind of a flat line in terms of 24 on where we'll continue to see this hybrid balance on where customers are really looking at and where the right deployment model is. Okay, step into Xeon 6. What does any of that have to do with the Intel architecture? Xeon 6 was designed from the ground up to address security, to address AI, to address traditional workloads, on-prem, in the cloud, and so forth. And I'm not going to read through every slide, gang, because there's way too much data to get through if we get super detailed. The part I want to point out on this, and I'm going to get into it a little in the next couple of slides, Intel is the only data center class CPU with these built-in integrated IP accelerators. So kind of top quarter on the right-hand side of this chart, designed to optimize performance in the parts of the deployment that customers care most about. They're running some level of AI. So there'll be accelerator engines for AI. Security is critically important. There's accelerators built in for security. Same thing with load balancing and so forth. And I'll get into what that means in a bit. So what does that really mean for you and your business? You can see here's the list of, this isn't all of them. It's not 100% exhaustive, but it's most of when we say accelerated compute, what's that really mean? It means that there are built native into the hardware accelerators for AI, security, HPC, networking, analytics, storage, and so forth that really do help optimize that performance. So why is that important? Today, data centers are being asked to do, kind of where I started, being asked to do significantly more than they were 4 and 5 years ago and 8 and 10 years ago. And I say 8 and 10 years ago because we know that there are servers still in use today that are more than 8 years old. And if you think about the hardware and software that existed 6 years ago, let alone 8 or 10 years ago, they are unable to keep up with what the requirements of a modern data center is today. VMs and containers and microservices and HPC and cloud and security and so forth. At the same time, data centers are being asked to do more. There's some major constraints. Power budgets. Every customer I talk to, seriously, everyone, power budgets are the number 1 or number 2 concern. We can't afford any more power into the building. Or there's a mid-size, mid-market customer I work with in California, we've been friends for a long time. He has a machine shop. The city told him, we can't bring you any more power. He wanted to bring some more machines into the machine shop, and the city said not till the end of the decade. Well, he can't expand his business because he can't get more power. So being able to more efficiently run his mainline machine shop business, but more efficiently run his data center freed up some power. The same thing with floor space. I don't have any more budget. I don't have any more floor space. How do I do more with my data center when I have these constraints? And then, as always, cost and TCO is a key part of this, right? Nobody wants to go, I can pay anything you want to get me the performance I need. It's what's the best optimized cost solution I can get that optimizes my business and brings me the performance I need without having to fire up a nuclear power plant, without having to build multiple new data centers. So the questions that most typically get asked, what do I do? I need to expand my IT capabilities. I'm worried about TCO. I need better performance out of my business, better performance out of my IT. Cost is important and so forth. We can throw more cores at the problem. For many years in the industry, that was the answer. More CPUs, more cores. We can do that. There's cost considerations, power considerations, licensing considerations, regulatory considerations, and so forth in doing that. We can throw specialized hardware at the problem. And there's been a host of different vendors over the years who have come up with some really, really cool solutions, but very specialized to help solve a particular problem. Again, more significant cost, there's power implications, software licensing considerations, and et cetera. We can do that. Or for most environments in enterprise data center, can we look at a solution that is optimized for the most common requirements, for the most common needs? That's what Xeon 6 is designed for. That's why I started with the accelerators. Everything that customers are looking to do within a standard enterprise data center, there will be corner cases and esoteric use cases all over the place. Somebody might say, yes, but what about? And I will agree. Many cases, the what about is you need something more specialized. In the vast majority of environments and workloads, most of which are mixed workload environments, having a optimized infrastructure that meet the dynamics of what customer facing today is critically important. That's why Xeon 6, and that's what the whole conversation about accelerators and accelerated compute is all about. We really can deliver, and I'll get into some proof points on it, using the standard Xeon that everybody knows and loves. You can deliver the performance everybody's looking for, keeping in mind the licensing power, performance, TCO, sustainability, security, all of it within a package that everybody already knows how to use today, is very familiar with. Okay, so we're going to go through. I think I have 3 of these in here, different polling questions. You should all see it on your screen. Go ahead and give it a shot. We tried to make this fun and not super complicated. Everybody should get an A on these tests, by the way. I will leave it there for 1 second, then I will click on.
I got a question for you while we wait.
Fire away.
When will Intel be releasing the Intel Quantum processors based on spin qubits? Will there be hybrid processors with this technology, and/or will they be compatible with existing motherboards?
That is a much longer question. The answer is the qubit quantum. There's been a couple different experiments. Somebody obviously follows Intel Labs. There's been a couple different projects with it, Intel Labs, for a number of years. Some around neuromorphic, some around quantum, and so forth, that are still in Intel Labs. Why that is important is until a product is, call it, ready for primetime use and is picked up by an actual business unit, it will remain a lab project. Today, none of what you're asking about is outside of the lab. Part of that is because there's not yet a robust application software ecosystem. I don't think you can run Windows Server or SAP on any of the quantum stuff. There's power and cooling and just thermal design and all the rest of it. So I'm not trying to hide a date of when this might hit the street. I don't know, because it's still in labs with a ton of work being done. But those are, again, real projects sitting in the lab. Us and all of our competitors have lab projects all the time. So it is a product that's being evaluated. But I don't have a timeline that I can share on when it comes out and how compatible it might be with a standard x86 or other ecosystem. Again, I'm not trying to hide the answer. I actually don't have a line of sight on it yet. Nothing's been made internally public even.
Excellent, thank you.
Okay, so I'm not going to run through a bunch of TCO org charts, or TCO, a bunch of TCO and performance metrics. I know anytime a vendor comes in, obviously we're not going to show that our performance in TCO is terrible. Xeon 6 really is the best in class CPU in this space. Better performance, broadest case of workloads, best price per dollar, best price per watt, and so forth. And I do have a couple I'll show, but I put this in here because this deck will be available to all of you afterwards. So you can go back and take a look at some of the finer details in here. And if there are questions, please reach out to your D&H rep. They can find us and we can walk through whatever anybody needs. Okay, so let's look at a couple examples of what we actually see happening today. This is a real customer, real example. We anonymize the name of the actual customer, but this was a real use case. Customer had a stack, and I think this actually was 50 servers. You can't draw all 50 in there; it doesn't fit in the slide. If I remember right, it was 50 servers that were running second gen Xeon, so 4th-generation old Xeon. They came in and said, "This is taking too much power. Licensing costs are too high. I'm not getting the performance I need. I need to expand just my IT budget or my IT capabilities, and we want to introduce a little bit of AI in there." So column 2 and 3 is what actually happened. So we did a node consolidation. In this case, it was a 3-to-1. They had some pretty heavy workload. So I'll show a couple slides later where the average node consolidation is about a 5-to-1. In this case, it was a 3-to-1 node consolidation. And then they could go add some dedicated AI capability in there with AMX from Xeon 6. If they wanted to, in this particular case, they didn't, but it was set up to do it. They still might. They can add dedicated AI training hardware. For Intel, that'd be Gaudi solutions. But they optimized the solution down, or optimized and reduced the footprint, reduced the cost, reduced the TCO, and added the AI capabilities they needed. And at the end of the day, they still saved themselves a pile of money and a pile of floor space and delivered the capabilities they need because of this 3-to-1 node consolidation. Now, what does that look like in kind of break it out in real life? Customers are not doing any one thing in their data center. They're doing data services. Maybe they're doing some HPC. Maybe they're doing some AI. In this case, it was image classification, web services, and so forth. It is generally a mixed workload environment, right? There are certain cases where somebody may have a dedicated HPC cluster, a dedicated AI training cluster, but in general, it's a mixed workload environment. So doing this refresh and consolidation, again, from 2nd-gen Xeon, which is very common in the market still today, 4 generations old, to the current 6700, just mainstream, middle-of-the-road Xeon, you can see the performance advantage just going Intel to Intel, and I'll get to in a second what this looks like, Intel to competition. But it is somewhere between a 4 and a 10, almost 10x performance increase. Significant performance increase going Intel to Intel. And then you can see the node consolidation, fleet energy saved. I see RFPs on a not infrequent basis anymore, where they want to know what's the actual CO2 and what's the fleet energy used. What's the CO2 emission and what's the actual energy consumption going to be? Because our grid is getting maxed out. And if you say power consumption is going to be X, it needs to be X. It cannot be 9 times X because we don't have the power budget anymore. So understanding what the overall fleet energy is, critically important. Rolls down to TCO savings and then the TCO percent. I like the TCO cost savings as part of this more than just the percent, because if you go to a customer and say you can save 20%, it doesn't really mean a ton to them because everybody in the industry says, I'm 10% this, I'm 20% this, and whatever. But if you can go to the line of business manager and say, I can save you $3 million. If you refresh this system, here's what the cost is going to be. Whoever your favorite OEM is that you buy through D&H, what's the cost savings? It's $3 million. They can very quickly analyze what's our payback. Is it 6 months? Is it 3 years? But it makes for a much more meaningful conversation to have when you start talking about doing this refresh and consolidation. As I mentioned on the last slide, the average we see in this environment is a 5-to-1 consolidation and nearly 40% TCO savings across the board. 5 servers down to 1, 40% TCO savings. And then you get on top of that the licensing cost savings, which is built into the TCO, but it's less licensing cost, smaller server footprint, less CO2 emissions, and so forth, right? And you get all the capabilities you would need because of the accelerated compute. You get the capabilities you need for security, for load balancing, for AI, and on and on and on, right? So it's a much, much more compelling solution. So of course, I'm going to get up. I'm the Intel guy, and I'm going to show Intel to Intel, and the new thing's going to be better than the old thing. This would be a terrible presentation if the new thing was worse than the old thing. So if anybody's going to look at refreshing their data center, of course they're going to look at AMD. I would recommend it as well, right? Go see what's out there. So let's look at the same dynamic. Same 6700, the green star at the top, same 6700 series CPU versus a 64, or I'm sorry, versus an AMD 9535. Try to do an apples to apples. So let's look at a couple different workloads, a couple different AI, web services, data services, and so forth. Intel versus AMD, performance advantage, somewhere between almost 10% better and more than 2 times better performance. You can see the server node consolidation, pretty significant. Fleet energy saved, reduced carbon emissions, and then somewhere between 13%. Data services is a more mature business, so everybody has performance tweaks around data services, AI and web services, and so forth. Really, the accelerators really are an advantage for Intel in this space, but significant TCO savings. But then again, when you go to a customer, you can say, you're doing kind of a mixed workload environment. I can save you somewhere between $1 million and $5 million, $6 million doing this migration from old stuff to Intel. And here's what that compare would be looking at AMD, right? So it's again, because of the accelerators built into the platform, we don't need to throw more cores at it. We don't need to throw more power at it. It's optimized for the various workloads that general businesses are looking for today. It's optimized for that, and this is a result of that. There are some environments where customers say, hey, I need more performance than just the mainstream, right? I need the top of the stack. For Xeon 6, that's the 6900. We see a lot of that in HPC and in different AI workloads where that next level performance really does matter and customers are willing to pay for it. So let's do that same look at top bin, not top bin, but the top of the stack on Xeon versus the top of the stack on AMD and some of these type of workloads. Again, we're seeing somewhere between a 30% and an 80% performance increase, Intel versus competition. Again, significant server node consolidation, great on the fleet energy savings, CO2 emissions, and your savings, again, somewhere between, call it $1.5 and $4 million, right? And you can see the TCO savings across the bottom there. So when I say it, I'm going to keep bringing this up. When I say Xeon 6 was really architected for the workloads that most enterprises, most businesses are looking for today, and accelerators were built native into the silicon to optimize for that, this is exactly what the outcome of that is, right? So it really is designed specifically for what customers are looking for today and creates a tremendous opportunity for you working with those customers to, how do we refresh? Here's the things we're looking for. Do I need to do a little HPC? Sure. Do I need to do some natural language processing or a chatbot or an agent? Maybe. This enables that without having to get into crazy customized hardware that brings with it a tremendous cost and power budget overhead as well. So I'm not going to get through, I'm not going to read all this, but so you'll have access to it. Looking at, again, the top of the stack, that 6900 versus the AMD 9000 series. Again, because of the accelerators built in, what are the performance advantages we see across a range of data and web services, a range of different HPC workloads, a range of different AI workloads? We could spend another 25 minutes going through all of it, but this paints a pretty good story of what it is. If customers really are looking for, hey, I really do need that performance across a range of diverse workloads, and I don't want to go put esoteric custom, some other hardware in there, what do? Xeon 6 is what you do. It really is the answer. Okay, second polling question. When compared with the latest generation, what I just talked through, second gen to current gen, what is the node consolidation, and TCO savings. Again, average across a range of workloads. Any one workload might give you a different answer. We should have the Jeopardy music playing in the background when we go through these. Let this sit for a second, and then we will continue. 5, 4, 3, 2, 1. Okay, let's take a second and talk about enterprise AI. This is not going to be a 20-minute AI conversation. I know you hear AI from everybody all the time anyway. Why I go through this is when people talk about AI and where the real opportunity is to really help a business, a line of business manager, an IT director, IT professional, really understand what is AI. It's a really broad term that in and of itself doesn't really mean much, right? So what everybody wants to talk about is generative AI, ChatGTP, BERT, Llama, right? Some of these big training models. Where most AI is in the bottom of that iceberg. These classic AI use cases, right? It's more than 2/3 of all the AI that happens today is traditional AI, machine learning, deep learning, natural language processing, and so forth. I'll get into a couple examples. So when a customer comes and says, hey, we need to do AI, I actually get that comment not infrequently when a CEO or board of directors calls somebody in IT or calls the legal department and says, what's your AI strategy? And they call and say, hey, Trav, we need to do AI. Well, there's a lot to unpack in that. Really understanding how customers are using AI and how they could and should use AI in their business becomes very important, more than just saying, here's a box that does AI, go buy that. So AI is the big circle. Within that is machine learning. We've been doing it for a decade. Within that is deep learning. We've been doing it for a decade. Within that, the smallest piece of that is generative AI, and that's the brand new thing people want to talk about. Very few enterprises are actually making the investment or need to do really their own from the ground up Gen AI. And I'll talk about what that means in a second. When I talk about, and I'm not going to go through every bar, when we look at the spend, 2/3 of the spend is on classic AI. That is growing, no doubt about it. Most of where it's growing is in a small number of very large cloud customers and a few others who have lots of time and money and expertise to spend on building out their own frontier training models. Most enterprises not going to do that. They're going to adopt agents, agentic AI in a legal department for document redaction, in a manufacturing line for image AI and defect detect, right? That's the kind of things where we really see generative AI or new AI happening, but that becomes, it's not frontier training model, it's agentic and it's inference is where we see most of that happening, again, focused on small, medium business, enterprise AI. If this was a conversation about hyperscale cloud, I'd have a different opinion of it, all right? And what we see that spend is different. But there really is a bit of a dichotomy between what traditional business and enterprise is doing and needs to do and what tier one cloud is doing, right? The big hyperscalers. When we look at just general AI inference, what most enterprises are going to do, and most cases they say we don't have power budget, we don't have floor space, or we don't have expertise to go do some dedicated AI thing, and that dedicated AI thing could be from NVIDIA, it could be a GPU from AMD, it could be a Gaudi GPU from Intel, right? I'm making a comment agnostic of who the vendor is. Most enterprises have asked, here's what we need to do. Could be one of 100 things. Intel, can we do that on the standard x86 Xeon architecture that we know, with the software ecosystem that we know, with the experts we have in-house for IT that they already know how to do this? Can I do this kind of AI? Can I do a chatbot? Can I do natural language processing? Can I do deep learning? Yes, across the board, because of the accelerators built into the CPU, yes, you can, and it works very well. When I do an average look across a range of workloads, trying to do AI inference, again, lots of enterprises talking to us about how they want to do their inferencing on standard compute, Intel compute versus AMD compute, it's better than 5x better performance on Xeon. Again, because of the architecture and because of the acceleration and the accelerator capabilities that are built native into the CPU. If somebody wants to ask the question and say, how does that compare to a big NVIDIA H200? It doesn't, and it shouldn't. It's like trying to take a minivan and race against a Ferrari. They're designed for very different things. If somebody wants to go do deep model training or tens of thousands of concurrent users, you need a dedicated AI accelerator engine. It could be a GPU, it could be Gaudi, it could be NVIDIA, it could be AMD. Most enterprises aren't doing that. They're looking at anchoring in on smaller language models, agentic inference that they can manage within their infrastructure. In that environment, it's a significant advantage, both price, performance, power, cost, to go with Xeon 6, again, with that natively built-in AI accelerator capability. I talked about small language models, not going to read through it. Because of the memory, MRDIMM technology, we get a 20 to just shy of 40% better performance over a similar two-socket EPIC solution, and you can see what they were looking at the bottom, right? Llama 3.1, Phi, ChatGTPJ, and so forth. When we talk about, and again, these slides are in here, gang, so you have access to it. I'm not going to read through all of I've got a couple of these. We looked at inferencing, talked a bit about agentic. Customers are also saying, I need to do natural language processing or speech to text, or I'm trying to run a RAG system, right? Text processing for, again, general enterprise workloads. Much, much better performance on Intel versus what they could do with AMD across a range of different ways they would set that up, right? Looking at BERT large and performance and batch performance and search performance and all the different things that people would do in these segments. Again, what Xeon 6 was designed specifically for. Same thing if we look at computer vision. One of my favorite examples on this, I'm assuming everybody knows who Panda Express is. We helped put a solution together. This is probably a year and a half ago now, and I think it's rolled out across all the stores now. So if you go to a Panda Express, you don't see it, it's not my fault, but they're still rolling out. Where we helped architect a computer vision solution for every one of their restaurants, little tiny cameras on top of the food, under the counter where you'd order, that can monitor the quality of the food, the temperature of the food, is the shrimp empty or not, right? So it monitors all that stuff, sends a signal back to the kitchen or back to a manager if there's something wrong, that can help manage and monitor every aspect of the entire restaurant. They have a inventory control system built into it that's in the cooler, right? So they say, oh, we're out of chicken here, we're out in the back, time to order more. This whole solution was built around standard compute, no fancy GPUs, no fancy custom hardware, but built around the basis of it was a computer vision system that runs really well on Intel, right? And you can see, again, a bunch of different performance benchmarks. But a lot of these, there's real examples. I have a friend with a machine shop. He does similar stuff for auto defect detect. There are a couple, it's not done yet, a couple very large fast food burger restaurants that are looking at deploying similar type solutions within their environments, right? It takes the error out, especially when you have restaurants particularly have high turnover of 17 and 18-year-old kids going to school and coming back and working for the summer. It creates errors just in their inventory control and quality control. This helps mitigate that. And it is a much more cost-effective solution than having to either hire more people or hire much more expensive people who are going to come and turn over real quick in a restaurant. And again, you can see just the performance differences we get on again, standard Xeon versus what you would do versus the competition. Last one of these, same thing on a deep learning system or on machine learning, right? Much faster and more relevant recommendations, right? We've been playing in this machine learning and deep learning space for a long time. It should be fairly familiar to most people on the call. But if there are questions or customers have particular opportunities we need to dive in on this or any of it, again, please reach out to your favorite D&H rep, give us a call. Okay, this is the last one of these. AI with Xeon 6 is the best CPU option and is optimized for, or the real question is, which one is it not optimized for? I'm hearing Jeopardy in my head. Off we go. All right. So closing this thing out, at the end of the day, Xeon 6 really is designed for exceptional performance, more cores and higher memory bandwidth than prior generation, very efficient, very much improved performance per watt with built-in accelerators, single socket to 8 socket scalability. There's no comparison in terms of security between what SGX delivered initially and what TDX delivers now in terms of confidential compute. Secure AI is becoming a real thing. You need security in your infrastructure. Customers want to do AI, do something with AI. Being able to marry the Intel security engines with what they want to do in AI is becoming critically important and showing up in more and more and more bits. Customers don't even know this is what they need until they get into it and they say, oh, all this AI, there's a security risk because it's AI. What do I do? Being able to have a secure AI conversation with them is critical. And then Xeon 6 is the foundation for AI. It is the best CPU for general enterprise class AI. If somebody says, hey, I really do need a dedicated AI GPU based system, NVIDIA picked Intel Xeon as the best host CPU. Some people call it a head node in the market. So if they need to go that direction, all the foundational AI, all the data work, the data prep that has to happen, happens on Xeon, not on a GPU. So even if you are going with a dedicated GPU Gaudi type system, Xeon as the head node is the best solution in the market. No question about it. If you have not seen this yet, Xeon Processor Advisor. It is a very easy, the link's in here. It's on this material is all available for you guys. If there's a question on how to access or use it, please let me know. Xeon Processor Advisor, if you say, I've got a customer that's got old Xeon, second gen Xeon, whatever it is, they want to migrate to the new thing. Here's the workloads. What's the actual TCO, performance, carbon savings, all the stuff they'd want to see? We have an automated tool that does it for you. D&H can walk you through it. We can walk you through it. Makes it super simple to look like an actual expert. Last page. So we hit super high point on a lot of stuff today. Anybody wants more information on Xeon 6, on the roadmap, on single socket, on AI, all the links for all that stuff is in here. If there are questions that anybody has other than qubits that I can't answer yet, that's not addressed here or otherwise, just again, reach out to your DNet rep. They'll find the right Intel person. Happy to help wherever we need to and wherever we can. And that is the end of this. I like to leave 15 or 20 minutes if there are A, questions we can address, or B, if anybody wants to use the time to go have a late lunch or take off early today. So with that, if there are questions, please drop them in the chat. I don't think we have a live mic question, but if there are questions, please drop them in the chat. Otherwise, everybody can have a few minutes back.
Awesome. Travis, thank you so much for going through those slides and presenting all that information. A lot of valuable stuff in there. One thing we'd love to hear from you. So if you have questions, if there's server configurations you need to put together, I can personally help with that. I can always work directly with Travis or really anybody engineering wise at Intel that might be able to help you with more technical deep dives. If you have customers that are in that development sort of world, and they don't really know what direction to go, one thing I would urge you to do is mention OpenVINO. It's a platform Intel's been building on for quite some time here. It really does make it easy to deploy AI on just a CPU, and it's pretty efficient. I don't, if you were at the Thread show, I think about a year and a half, almost 2 years ago, we had a demo of that uncompressed AI models running on a laptop CPU. So there's a lot you can do there. You don't necessarily need expensive GPUs if you do want to get. One other thing I'd like to mention, if you're interested in the lab stuff we do here at DNH, I just brought in a Dell R770 with 6737P processors in it. We're going to be standing that up in the lab. We're likely going to be deploying Proxmox on there. I've been hearing from a lot of you that you're looking for VMware alternatives ever since the Broadcom acquisition, and that's completely understandable. And Proxmox is coming up a lot. I've been personally working in that ecosystem for about 10 years now. I'm very familiar with it. If there's things you want to see tested or run or anything like that, or driver support, we're going to be doing a lot of that. So feel free to reach out, and we're happy to share our findings as we go through that. And we're happy to spin up anything else on there for you if you're just looking to make sure something works or looking at specific performance metrics on Xeon 6. I know a lot of you are going to be coming off the second gen Intel Xeons. I'm seeing a lot of transitions there up to Xeon 6 and server consolidation. So we're happy to help. Hopefully we'll have a lot of good information coming out of that for you. Again, please feel free to reach out. You can cast a wide net here at D&H. You can reach out directly to me with anything Intel related or server or data center related. My email address is mflickinger, FLICKINGER at dndh.com. You can also get me at techsolutions at dndh.com. That would be an alias you would use more for technical help on building out servers, and I can support you whether you prefer Supermicro, Dell, HP, Lenovo, and Asus as well. We have all of those options for you. So whatever you prefer, I'm very familiar with the platforms and different options there, and can spin up a quote for you, no problem. But yeah, we always look forward to hearing from you. It's always fun to hear what you're working on, what markets you're in, what your customers are doing. Please let us know. It gives us a better idea of how we formulate content to provide to you, and hopefully make things interesting and just keeping that kind of scaling in the right direction. But yeah, that's pretty much all I had. We'll, like Travis said, we'll leave the Q&A open here for a bit. Yeah, we got plenty of time. Feel free to drop your questions, leave a comment. um, you know and yeah, I just want to thank you again for being here. We really appreciate you taking time out of your day to be here with us. It does mean a lot. So again, thank you so much. Travis, thank you so much. Really appreciate you being here today with us.
No, appreciate the opportunity. It's great to connect with you guys. Again, the questions, let us know, right? If it's not valuable for you, it's not worth anybody's taking their time. So make sure you use the resources at your fingertips.
Yep, absolutely. And Intel Specialist at dndh.com. There's another one. You can reach me there as well, or if you just have general Intel questions, feel free to shoot them there, even client related stuff. No problem. Happy to answer that for you.